and relate some courses with some faculty or some users. So we have these new courses. We have we need just like we interacted with users by inserting and creating and deleting and whatnot. We want to be able to do the same thing with courses. So we'll need, just like we did for users, we'll need a repository also for the courses. So we'll create an interface, and this will be the course repository, and this will extend the CRUD repository, and we'll configure it so that it's a repository that will allow us to interact with course, and the primary data type is an integer. Okay, all right, excellent. Once we have that, let's see if we can create a couple of courses. We'll create also a controller that will allow us to insert a couple of courses there. So let's this will be the course controller, and in here we'll say this is a REST controller, and we'll say public course create course, and the title will be the title right here. And basically what I'd like to be able to do is just save a new course, right? We'll say course, new course, and we'll set the title. That's all we have, right? We can say course.set title, set title, title, and then we want to save it using the repository. And the repository, we're going to auto-wire it here. This will be the course repository. And here we can say repository.save, and here's the course. And we'll return the course once it has been inserted, right, with its ID and whatnot. Right? So let's create a couple courses. And what the interesting part here is that when you start looking at the JPQL, that allows us to now navigate between these two. Right? Usually, the way you navigate in using SQL is by making the primary and foreign key being equal. Right? You join the two tables. You say from table 1, table 2, and then you do the join. Here, because JPA tries to shield us from any low-level SQL and keep us as much as possible in the object realm, the navigation now is different, right? You do not, make things equal like that, right? Instead, you can navigate using dot notation, right? It'll be user.courses, right? Dot whatever, right? Title. So it's going to find me the course from this user and whatnot. So the join now is completely implicit. All right, so let's try and create here. Oh, I don't think I mapped it, did I? I never mapped it, sorry. So this will be get mapping, and this will be something like API create course, and the title. Sorry. Let's map this to a path variable called title, and to that string. Okay. A couple other things here. Maybe if you want to be able to retrieve all the courses, you can say get mapping, something like API / courses. That should just retrieve all the courses, right? So that would be public list course, find all courses, and this will be let's see, return list of courses from the repository dot find all. Right? Okay, excellent. So let's compile both of these. All right, and let's run this. So here we want to do something like we want to create a course, and the title is CS5200. Okay, so it comes back. It comes back saying, yep, I've created 5200. Well, let's create a couple more. CS5610, CS5500. And if we go to the database, presumably the courses are there. Yeah, those are the three courses. Nobody owns them. They have no users, right? And we can retrieve all of them. We can just say courses. Gives me all the three courses. Perfect. Now, what happens if these would have the IDs of courses, right? Who owns them, right? Notice that this is user up here, but is user ID down here. You see that user ID? Let's say Alice owns 5200. 5200, and so these two are owned by Alice. And this one is owned by someone else. So let's apply. Oh, so those two of them are owned by one, and one of them is owned by somebody else. If I refresh, notice that it gets into an infinite loop. It gets into an infinite loop. And the reason it gets into an infinite loop is the following. What it's trying to do is trying to convert this infinitely as follows. Where is our course? It's saying, it's getting to the user. It says, oh, you have a list of users, a list of courses. Oh, great. And well, I'm going to try and convert them into an array of objects. And I'm going to walk each one of the objects and try to convert it. So I'll go to the course. It says, well, I need to convert the title. I need to convert the ID. Oh, and I need to convert the user. When it gets back to the user, it gets back to the original user where that has the same array of the same three courses. So it gets into this infinite loop of trying to walk the pointers, right, of the users down to the courses up to the user, and the user down to the courses. So we need to break that. We need to break that at some point. We have to say, well, either the users know about the courses or the courses know about the users, but not both of them, right? So what we're going to do is we're going to say that we're going to break it here. We're going to say JSON ignore. Ignore. Where are you? Here. So don't try to convert the user. Don't try to convert the user. Otherwise, you're going to get into this infinite loop. All right, excellent. So let's try and use that. Notice that this to also get into this infinite loop. And I mean that's common, right? In even just programming plain old Java, right? Of trying that you can get into these problems of these cyclic pointers, you know, and this is just an example of that happening here. Right. So here, if I say localhost 8080 and it was API, what was it? Just courses. I now just plain old get the courses, but the user is nowhere to be found, right? So it didn't even try to convert the user. But if I go the other way around and I go to the users, notice that Indeed has walked all the way down to the courses, right? So for instance, notice that you know, I have the information about the user, plus all the courses that are taught or are owned by Alice, and I also have the courses by Bob, and then Charlie doesn't own any courses. See that? Right? So from the point of view of the object is entirely loaded into memory. Right? It has its own fields, plus it did another query joining itself with the other table to retrieve all the records that belonged to that particular record. See that? So it joined them up into memory. So this brings up a particular issue of saying, wait a minute. You mean that if you know, what if this parent is associated with, you know, hundreds of other records? Does that mean that all those records are also going to be loaded? Right? In a Java program, that might not be an issue, right? Because you know the instances that you're working with, right? But here, when you try to map it to something that might be hundreds, thousands of records, who knows, right? That need to be loaded into memory, then it becomes a serious issue on whether you actually want to do that, right? If you want to be able to control, right, which actual fields that you want to load from memory, right? And the least, the better. Okay, it could be that you're just listing the users, and your query might just want to just retrieve the users, regardless of what courses they're teaching. I want to list the usernames, maybe. Who cares what courses they're teaching? So you want to be able to control whether the loading of the relationship of any field, any records that are associated, whether it's eager or lazy. Are you lazy loading or are you eagerly loading? The default is to eagerly load the data, right? If you have a parent and you have all these children, the default is to eagerly load the children of all the parents, right? Which could be very expensive, right? But it could be configured to be lazy loaded, meaning I'm not going to load it. I'm not going to go and do the join and retrieve the records, the child records, unless you explicitly ask for the courses. If you explicitly ask for the courses, I will do the join and I will fetch the data on demand. Okay, and then I'll provide that array on demand. All right, and so we'll take a look at that a little later. But it's something to consider. So we were able to notice that the way we created the relationship here was by manually updating the foreign key. All right, that was cheating, right? So we were able to insert the records, certainly, but we'd like to be able to control this. Right, we'd like to be able to control this programmatically, not doing it here. So we set them to null. Null. Can I set this to null? Okay, so I sent it back to null, right? So that means if I go back here and I list for this, notice that the courses is empty, right? Nobody owns any courses, right? So let's see how we would do this programmatically as opposed to cheating in the database.